Hello guys, this is Dr. K from Next Level Math and Physics. Today in this video, I'm going to show you how to find the torque. What is a torque? Simply, it's a twisting force. So that means you need a force and a distance to the force from something called a pivot point or a fulcrum. So let's see how to solve some problems where we are trying to find the torque. So this is the first problem. As you can see, P is the pivot point, and then there are two forces, one 5 newtons, 2 meters from the pivot point. And then there's a 2 Newton force that is 10 meters from the pivot point. So these distances to the respective force from the pivot point, that's what we call the leverage. We call this the leverage. It's called the leverage. Okay? Sometimes it's called the lever arm distance, but simply you can call it the leverage. So how do we find the torque? First, we need a convention, okay? Because torque is a vector. So that means there's a size and a direction. So our convention is, it's going to be like this. Can you see this 2 Newton force about this pivot point? It's going to create a twist in this direction, like a rotation in this direction. So that's a counterclockwise rotation. We call it a counterclockwise torque. Okay, so counterclockwise torques are considered positive. They are considered positive. And then look at the 5 Newton force. That's going to create a clockwise torque. It's going to create a clockwise torque about our pivot point. It's going to create a clockwise torque. Okay, so then the convention for clockwise torques, that's going to be negative. That's going to be negative. So that's our convention. If it's a counterclockwise torque, that's positive. If it's a clockwise torque, that's negative. So based on that, let's try to find the total or the net torque about the pivot point P. So I'm going to write, net torque I'm going to first consider the 2 Newton force, the torque due to 2 Newton force. So that's going to be a positive torque. So plus 2 newtons times the leverage. Look, that's 10 meters. And then the next one, 5 newtons, I told you that's going to create a negative torque, a clockwise torque. So I need to put a negative sign here. I need to put a negative sign, and that's going to be 5 newtons times the leverage there. That's 2 meters. That's 2 meters, okay? And then look, then we have a final answer. From here we have plus 20 Newton meters minus 10 Newton meters, and then the answer is plus 10 Newton meters. That's our answer. That's the net torque about this pivot point P. And the plus sign indicates that the net torque is a counterclockwise torque. Based on our convention, it's going to be a counterclockwise torque. So that's how we find the torque. In this case, it's a net torque. Now, I have 2 more examples. Now, this one, the one that I did, it's pretty simple. Because look, we can call this the leverage or the lever arm distance simply because the force is perpendicular to that distance. The force is perpendicular to that distance. Both these forces are perpendicular to the distance. Okay? But now look at this example. Look at this example. Here again, I have the pivot point P. Okay? I have the force 10 newtons in this direction, and then I have a distance 5 meters, but that's not what we call the leverage. Why? Because the force is not perpendicular to this distance. Can you see? It's at an angle. It's at an angle. It's not perpendicular to the distance. So what we need to do here is we need to find what's the perpendicular force component to that 5 meters. Okay? This is one way of solving this problem. So I'm just going to talk about this method. So what I'm going to do is that I'm going to find this component. Can you see this vertical component? And that component is going to be perpendicular to the 5 meter distance. So then the 5 meters will become the leverage or the lever arm distance. So then how do we find this component of the 10 Newton force? So that's going to be, if you remember your trig, that's going to be 10 cosine 30 degrees. 10 cosine 30 degrees. Okay, guys? Okay? Right. And now we can use the same approach that we did in the previous example. We know this component 10 cosine 30, and then we are going to multiply that by 5 leverage, and look, that's going to create a counterclockwise torque. That's going to create a counterclockwise torque. Okay, so then how do we get the torque here? In this example again, we can find the torque. Force is 10 cosine 30. That's newtons, right? Multiply that by the distance, which is 5 meters. And this is a positive value. That's a positive value, okay? Because it's going to introduce a counterclockwise torque. So here, then when you solve the answer, so that is 50 cosine 30 degrees Newton meters. Substitute for cosine 30, 40 positive, okay, it's positive 43.3 Newton meters. That's the answer. So that's how you do this one. Okay? Then the last one, look at this one. Again, we have the pivot point. There's a distance 5 meters. But then that 5 Newton force is not perpendicular to the distance 5 meters. So then we need to find the perpendicular component of that force. Look at this again, it's trigonometry. I'm going to draw a perpendicular line. So that's 150. If this is 90, then what's this angle? That angle is going to be 60 degrees. You need to remember your basic math. That's 60 degrees. So then when we look at this component, look, that's the perpendicular component. So that's going to be the cosine 5 cosine 60 component. And this will create a torque that is what? That's going to be clockwise. So it's going to be a negative torque. So here I'm going to do it quickly. So the torque here will be a negative 5 cosine 60 times 5 Newton meters, and that's going to be minus 12.5 Newton meters. So that's how you do that one. That's how you do that one. So that's how you do these problems. Okay, if the torque is counterclockwise, that's positive. If the torque is clockwise, that's negative. Okay, so that's how you do torque related problems. That's how you find the torque.